Okay, so should we start, madam?
Yes, sir, definitely.
So welcome, friends. Start with a smiling face. Okay, so hopefully you had a good lunch. Okay, uh, before I proceed further, let me summarize what we were discussing in the previous session. We started discussion with limited value dependent variable model. Where my dependent variable is having binary values. That's the model we started with. And to begin with, we started with linear probability model, and we find it has many problems, and therefore we discarded it. So whenever you use friends linear probability model, okay, then we talked about nonlinear models, which are based on S-shaped function. In that category, we selected cumulative, standard, normal, probability distribution, and logistic function. And this gives me probit model, and this gives me logic model. And both the models are estimated using a maximum likelihood method. The estimates which we get, that's your y hat. It is interpreted as, probability of success. That in the case of LPM. In a cumulative probability distribution, we get the value of Z, and you can get the probability of Z corresponding to, you know, small z greater than equal to z from normal probability distribution tables. Okay. In the logistic regression, we get probability by making use of this function or e to the power z upon e to the power z plus. Another way, you can calculate the probability. Okay. So friends, that was the point where we stopped. If any one of you have any questions, then most welcome. Okay, right. So no questions. So everything seems to be fine. So let's go further. So once a logit or probability model is fitted, then the question arises, how best the fit of the model is. Okay. I think before we proceed further, let's take some exercise on e-views. So I pick up some files. Open. We have files for profit and loss model. Okay, so let me take this. Okay, sorry. I need to pick up another file. Suppose I take a brand data file. So we are taking a problem, and the problem is what makes a company's brand more valuable. Okay, and when I say more valuable, that means do we have a strong brand or a weak brand? And what are the factors which you are considering here for the determination of this brand are as follows. So we have market share of the company in the market, profit margins, and the size, whether the company is a big size company or a small size company. Okay, so my model suggests that brand which we have here is a function of market share, profit margin, and size. Since we are considering two classes of brand, strong brand and weak brand, therefore my brand is a binary variable. And my model becomes that brand is equal to alpha plus beta 1 market share plus beta 2 profit margin plus beta 3 size plus error. Is that clear? And you can estimate it by using profit, and you can estimate it by using logic, depending upon what kind of underlying nonlinear function you are considering. Okay, so once we are clear about the structure of the problem which we are going to discuss, let's see how do we proceed with it. Okay, so go to view. In that view, you will find an estimate equation, and in equation you look for method, the binary. Okay, let's see how do we do it. So go to quick estimate equation. Brand is my variable, which is dependent variable. Market share is my independent variable. Profit margin and size and a constant. So I have written the components of the equation. Then you go to the methods and select in the methods you go to the methods, and in that method you click on binary, and the moment you select binary, it will give you options probit and logit, and you pick any one of them and you will get it. Okay, so I pick the probit and I say okay, that the result which we get. Okay, now suppose I want to find out the probability of a particular object, then let's see how do we get that. Sorry. I take to the Excel and I paste this output in the Excel, and then you can calculate the probability. And if you see here, it says the method is a binary probit method. And that's the output I have copied here. Is that okay? Any questions so far? Then suppose somebody is having I take some value from here itself. Suppose market share is 26, profit margin 24, size is 0. 26, 24, 0. Then my Z will be equal to sum product take the product of these coefficients with these numbers. Sorry. That's the value of the Z which we get. And then we can calculate the probability. For probability, you have to use the norm distribution, norm S, that's Z, relative, true, that's the probability. That's how you get the probability. Any question? Prateek ji, I will come back to your question regarding logic versus profit. Okay, but let's first do both of them, and then I will come back to your question. Give me a time. Okay, but if you don't want to calculate, you want to forecast using EViews utility. So there is a forecast facility. Here you can put your name of the variable. Suppose I say prop. Okay, then that's the graph they are showing. If I want to see the probability here, if you see the first one is having probability of 9.964430, 0.964430, right? Same probability which you get here. 96443, 96443. I can increase its decimal. Maybe some fractional differences because of the approximation. Okay. If you want to get the probability for another number, say (46, 28, 1). Okay, let me take this 13th observation. 35, 17, and 1. 35, 17, 1. 0.998285 the probability, and 0.998285, 0.998285. So that's how you can get the probability from the profit model. Okay. Another thing which I should discuss, and that's about the marginal analysis. These are positive numbers. What does it mean? Higher market share, higher profit margin, larger the size. All the three makes a company more probable in having a strong because all of them are having a positive sign. That means more of it will mean more probability that the company is having a strong plan. In other words, if a company is, if you want to see a strong brand of a company, you have to increase the market size, you have to increase its profit margin, you have to increase its size. If you're doing it, then you can make that company's, brand more strong. Okay, that's how we interpret these coefficients. Okay, if I run the logic module, then let's see what we get here. Same equation which we have here. Instead of selecting profit, you have to click on logic. And then you say, okay. And you get the results. If I copy this result and paste in, Excel, and these are the results which we have here. Okay, I hope you are able to see it. Now I want you to, this is my output data. Suppose I take the values, say market share 60, profit margin 25, size is small, my Z will be equal to some product of these values and these values. And the probability value will be, I'm using the logit function. So my probability value, if you remember, is 1 over 1 plus e to the power, that means the exponent of minus this, and that's the probability which we get here. So friends, I hope you understand how do we get the probability in case of a logic model. The equation which I've used is the probability is equal to, sorry, the probability is equal to 1 over 1 plus e to the power minus j. And you can also calculate the probability here. So you go to forecast. Okay, so I take probability logic. If I take the 16th observation, probability is so much. Sixteen, 19, 15, and 1. 19, 15, and 1. So my probability is 0.706924, 0.70693. So what we have learned, two things we have learned in it: how to run logit and profit model on EViews, okay? And second, how to calculate the probabilities. Probabilities I'm calculating by taking the output to the Excel. And these are the formulas which we have used for calculating the probabilities. Any question you have? Okay. Pratik ji, I will take your question first. Which one should we use? Should we use profit model? Should we use logic model? Okay, so Dr. Elder, I will come back to you for the book, but let's take this question. What do you think, participants? Should I use profit model? Should I use logic model? Which one I should use? The main difference is that of the underlying distribution. Logistic distribution has comparatively fatter tails as compared to that of the profit model. Most of the time, both gives you the same result. We hardly find any contradiction, but majority of the time you will find people prefer to use a logic model because of its comparative mathematical simplicity. See, if you remember, the formula was to get the probability integration of 1 over root 2 pi e to the power minus z square. So dealing with integration is a difficult job, and logic doesn't have that kind of, complexity. Logic says P is equal to 1 over 1 plus e to the power alpha plus beta x plus error bracket. So you can easily calculate change in P with respect to change in X, but it will be difficult here to calculate change in P with respect to X. So further mathematical processing becomes difficult in case of a probit model, and therefore you will find most of the cases people prefer to work with logit module and not with probit model. So, Mr. Pratik, it's not a question of logit versus probit in terms of the quality of the estimates. Both gives me the same quality of the estimates. The final selection is based on the comfort, ease, and further manipulation of the results. That ease comfort is provided by logit, and therefore you'll find most of the time people go for logit model rather than probit model. Okay, then another question which we have to decide is how do we know which model is the best model? Can we use R squared or registered R squared for determining goodness of it? The answer is no. Can any one of you think why this is no? Hmm? Because R square, adjusted R square, they are meant for OLS and not for maximum likelihood estimates. And therefore, you cannot decide on the basis of R square or adjusted R square which model is a good model. Then what should we do and how do we decide goodness of it? For that, we use one of the statistics which is called log likelihood statistics. Can be used to gauge goodness of fit of the logit or the probit model, and it's defined as some softwares provides me 2 minus 2 LL or minus 2 log likelihood values. And to get a positive number, we take the absolute value, and lower it is, better considered to be the fit. So instead of using log likelihood, some people suggested we should use a log likelihood ratio. Okay. Then instead of using R square, similar to R square, we get in logit probit model, which is called pseudo R square. They behave like R square, but actually they are not R square. And therefore, they are called pseudo R square. They mimic R square. Okay. And in that, the most famous R square, pseudo R square is McFadden's R square. And that is the formula which is used to calculate McFadden's R square. Then we have another measure of pseudo R square, that is Cox and Snell, and that's the formula which they gave. Then we have Nagelkerke measure, which is adjusted, which has adjusted the Cox and Shell to get the maximum value in one. Okay. So these are the some of the indicators that can be used to gauge the, like here we have a McFadden R square. You can also make use of the information-based criteria. Okay, you can also use log likelihood function. like this. But remember, they will help you in deciding, model within logic or within profit, but they will not help you in getting an idea about the logic versus profit. Okay. So, for example, we have an estimate, right? So we have an estimate with market share, profit margin, and size. What I do is I freeze it and suppose I re-estimate model with one of the variable dropped. Suppose I don't take C here, sorry, size here, and then I want to determine. So that's the model which we get. Now I can compare whether this model is a good model or the earlier model is a good model. And for that, you can compare the McFadden's R square, 64% and 75%. It's more, the model is a good model. Okay. Then we have likelihood functions. Or if you don't want to compare, it doesn't matter. You can compare the information-based criteria. Like here, the value of the information criteria is, you know, larger as compared to this. And therefore, this model is a better one. So friends, that's Prateek ji, what is ML? I don't understand. What is that you are referring as ML? AIC understand. What is that ML you're talking about? Prateek ji, what is that ML you're talking about? AIC criteria and criteria. But what is ML? Prateek ji, are you there? ML का क्या मतलब है? मुझे नहीं क्लैरिटी उसके बारे में. Okay. Anyway, so what we have learned the following one. We have understood how to estimate, how to get probabilities, okay, and how to decide which model is a better model. Uh, Prateek ji, you mean to say you're talking about maximum likelihood function? I don't know. Are you talking about log likelihood value or what? If you're talking about it, of course, you can also compare log likelihood value. Okay, right. So Mr. Rahman is asking for what AIC and what, in fact, all these information-based criteria mean. AIC and BIC, Bayesian showers criteria, and your HQ. And anybody would like to react what all this information criteria represents? What they represents? And why do we call them as information-based criteria? Anyone? Hmm? Anyone? Uh, yes, Pratik, somewhere they're related to the log likelihood function. But if we look at the concept level, they represent loss or so friends, whenever we work with any data, that data is having some pieces of information. Okay. Suppose I say that's my information set. And to determine my estimator, suppose I make use of this part of the information used. Then the remaining unused, which you have here, that will be reflected by information based criteria, AIC or you know BIC and others. So basically, how much information you are losing in the process, I'm saying it in a very crude sense, how much information you are losing in the estimation process. That is what is being revealed by, information criteria. And we would like to have as minimum value of it as possible because I want to get the best use of the information for calculating my parameters. So, Mr. Rahman, that's I can tell you in brief. Okay, we don't have much time to go into detail of it. Okay, so that's a feeling you can have about information-based trading. Prateek ji, in a way, you can call it a loss function, but loss of information. Okay, and those who are aware, the information is measured in terms of entropy. Most of them are based on entropy concept. Okay, great. Let's see what next. So researchers doing research wants to know what determines strong and weak brand that we have already done. And you can see here the strong brand and the weak brand, they are having two different sets. Okay. We obtain the profit model and we obtain the following logic model, and then that's how we get the estimate to the probability value. Okay. Which one should we use? That we have already discussed. So I said again, compared to the any other model. Okay. Now the question is, what is the relationship between the profit margin and market share and the probability that a firm will have a strong plan? How do we get that? Okay. For that, you actually have to do the margins analysis. Okay. So let's note down certain points. Sign of coefficients show the direction of relationship. That's important. So if the signs are positive, that means more probability of that, sorry, higher the particular value of a particular variable having positive sign, the chances that the observation fall in the category of success is also high. If it is a negative sign, then higher of x will lead to lower of probability that it belongs to the set of success. Okay. Next, like here, the sign is positive, and as your market share is increasing, probability is also increasing. And I can show you how can you make this graph in Excel. So we have here, suppose I take market share starting from say 10, 11, okay. Sachin, are you there?
Sorry, sir, Sachin sir is not here.
अच्छा मैडम आप बताओ मुझे ग्राफ बनाना है मार्केट शेयर का और कॉरेस्पॉन्डिंग प्रोबेबिलिटी का तो कैसे बनाना है हाउ आई विल डू इट इन एक्सेल anybody I took the probability here and you can make use of data tables. Just let me select. Then go to what if data table and my column input is market share 35. and you can make a graph of it. So that shows that as your market share is increasing, the probability is increasing at a decreasing rate. So that shows a positive relationship. And suppose if you make it negative, then what happens? The relationship changes and it becomes negative. So this sign will tell me the relation between, the direction of the relation between the variable and the corresponding probability. Similarly, you can also study the relationship between the profit margin and the probability of a strong brand. Second, what is the interpretation of the beta? What is the interpretation of the beta? What beta represents? Hmm? What beta represents here? My estimated equation is brand is equal to 0.234 market share plus 0.464 profit margin plus 3.424 size plus error. This is my set. Okay, what is the interpretation of these coefficients? Anybody? What is the interpretation of it? 3.424 for the size. Any one of you? What does it mean? If you remember in the logic module, Z is nothing but log of odd ratio. So if my size increases by 1 unit, then the log of odd ratio will change by 3.424. That is the interpretation of my beta. Is that interpretation clear? Beta is interpreted as the effect of a unit of X on the predicted value of logit or log of odd ratio. So you can say these are the change in change in log of odd ratio for a change in market share. That's how we understand this. Okay? And you know what we are doing? We are trying to understand each and every part of the output which we get to get more clarity about it. Third, we have what is called exponential values of the beta. Okay? So that means e raised to the power beta. And this exponent value of the beta is represents how one unit change in an independent variable will cause a change in the odd ratio. Because you have a log of odd ratio, okay, suppose that's equal to change in this over x, that's equal to beta. And if you take NT log of it, you get the change in odd ratio for a change in x, that will be e to the power beta. So the exponent of the b, e to the power beta, will represent one unit change in an independent variable will cause a change in the odd ratio. If beta is positive, the exponent of the beta will be more than 1. And if it is negative, then this will be less than 1. Okay? So the change in the odd ratio for a unit change in independent variable will be the times equivalent to exponent beta. Okay? Then how to get the rate of change in the probability for a change in x? That's how we get this value. And since the probability values are changing at every point, so this rate of change in probability for a given change in x will also change over a period of time. आपको समझ में आ रहा है ये हो क्या रहा है? Vikas Singh ji, your question about use of AIC or BIC, I will come back to that, but let me finish this discussion here. Okay, Vikas ji, right? ये क्या बात कर रहे हैं हम लोग? We are studying the change in the probability, the margin analysis, what we are doing for different values of the beta. Sorry, different values of the independent variable. Suppose I take the market share. Suppose I started with 0, 1. And suppose I go to 70. The analysis which you are doing is called margin marginal analysis. And the formula for the marginal analysis is the change in probability. Sorry. The change in the probability. Sorry. With respect to x is equal to beta into p into 1 minus p. Okay, so my probability here is beta. That's I'm calculating for the market share. This is my value of the beta into probability into 1 minus probability. That's the value which we get, but the coefficient was not negative, the coefficient was positive. That means at this point of 35 market share, if you change your market share by a small amount, the probability will go up by so much amount. That's the meaning of it. Okay, let's see how do we do it. Suppose I put this formula here and I make the data table in search. Uh, sorry. So first I have to define data table, and my column input is 35, and then I can make the graph. Sorry. So I think I've taken wrong data. I should start from here. Okay, that's the market share. And that's the probability, change in probability. Okay, objective is make and stronger. मैं आप लोगों से इसका पॉलिसी implication जानना चाहूंगा कि क्या होगा. Suppose you are in the management and you get this information. You want to make your company's data brand stronger, and the analyst gives you information that as market share increases, the change in the probability of making your brand stronger goes like this. बताइए क्या मतलब होगा इसका, इस ग्राफ का क्या इंटरप्रिटेशन होगा. डॉक्टर कृष्णन, आर यू देयर? प्रतीक, रहमान, Dr. Alder, any one of you give your policy recommendation here? Anybody? After 30, market size, no increase. What does it mean as a management? What does it mean? What does it mean? Dr. Rahman, what does it mean in terms of the policy implication? Management should not spend money to expand market share beyond 30. So if you already have market share of say 50%, right? And you want to make your brand stronger, and for that you are spending a lot of money, that will not give you the good results, because the chances of improving your, the probability of improving your brand is almost negligible. So forget about it. Don't do that. You should concentrate when you have lower level of market share. That makes your probability of making your brand stronger. That's how you can understand this particular graph. Okay, that's what we have done now. Okay. Uh, sorry. Right. So dependent dummy. I suggest use logic model. Get output. And once you get the output, what next? You have to do interpret the results. In the interpretation of the results, you may be asked to determine probability that you can do. You can do the marginal analysis. That is what will happen to your probabilities when a particular value of the independent variable changes. That you can do. Okay. And one more thing we have missed so far, how to know what is the success rate which we have in our model. So if you want to find out the success, you go to, sorry. That's the equation we have. Suppose I estimate with the size also. Then if you want to know what is the success rate, so expectation, prediction, evaluation, success if probability is greater than 0.5. By default, it takes a threshold probability 0.5, but if you want to change, you can change that. Okay. So 33 are having a value. Sorry. You can see here percentage correct. This one. Okay, how do we interpret this value? 94.29%. Any one of you? That means in cases of weak brand, our model is able to predict correctly in 94.29% cases. That means 5.71% are my error in the weak brand category. In the success category, okay, the strong one probability is 92.50. That means the error in it is 7.50. And if I don't make a distinction between weak and strong, I take the overall, classification, then my success rate is 93.33% or 6.67% is my error. So it's not big, so that shows we have a very high success rate and our predictions are very good, so we need not to worry about it. Okay, so friends, we have understood the different aspects of the logic and profit model and use it when you find that your dependent variable is binary or dummy variable, and that's how you can look at all facets of the model. Okay, any question now? Any friends, any doubt, any query if you have? Anyone having any query? Okay, so Dr. Elder, you were asking about the book. So I tell you the You start with a basic book. Either you go through to the Gujarati or Woolrich. They are more than sufficient. Okay, if you read them, you will get everything about logit and profit model. Okay, then there was one more question about, yes, when do we use AIC and BIC? Because normally we use both of them, and both of them give us the same decisions. Hardly you will find any one of them is giving, you know, contradictory results. So depending upon the sample size, so normally for a bigger sample, people say that you go for BIC, and for a smaller sample, you go for AIC. But there are all rules of thumb. Okay, so it depends how you take it. So friends, I hope you are able to get the complete view about the logic profit model. Any one of you have any doubt, you let me know. So I hope at the end you must be feeling comfortable with the logic profit model, and you will not be afraid of using them, and now you are capable of properly interpreting them. Okay. So what next? Nothing from my side. That's all from my side, friends. And hope that finally you will feel that something new you have learned today. We are feeling happy because in us a new knowledge is taking birth. So hopefully today you will be finding a lot of learning, and we are happy with that. Okay. Trust that you must be feeling comfortable with logic and profit module. And please remember, it's a beginning for all of you, still a long way to go. And the more you read and practice, the more comfortable you will be with all these models. Okay? Anybody else? Any questions? Don't forget miles to go before I sleep. No substitute for the hard work. The more you put in your hard work, the more will be the results of the fruit you will get. So thank you very much, all of you. Thanks a lot. Enjoy. Have a good time.
Dear participants,
Krishna,
any
Rehman, Pratik ji, Dr. Alder, everyone. Thanks a lot.
dear participants, any question, any view, any thought about this session? Dr. Haldar?
Hello. Yes, sir. Hello.
Yes, Haldar ji, we can hear you.
यस सर, मेरे इसमें क्या थोड़ा सा इंटरनेट की कनेक्टिविटी की कुछ प्रॉब्लम आ रही सर, एक बार फिर से बताएंगे? पार्डन व्हाट यू हैव सेड प्लीज.
I'm just asking you, do you want to share your feedback about this session?
Yes, sir. Yes, sir. 100%, sir. I would like to share because Dr. Chandra Gupta, sir, made it very interesting, simply, and very understandable for us, those that do not have the greater idea about the econometrics, time series, logic, and profit model. Even though we have the little bit amount of the probability and something like that. But in spite of that, what the teaching sir has adopted, I would also like to make myself, if sir bless us on the same. So I would be also be make myself like the teaching of the Chandragupta sir. Thank you, sir. Thank you very much, sir.
Thank you, Dr. Alder. Thank you very much.
Dr. Neha?
Hi, sir. Hi, Chandra, sir. This is Pratik this side.
Yeah,
Am I
Pratik.
audible?
You are audible.
Chandra sir, this is Pratik from BHU, and thank you so much for sharing your thought and explaining a mathematical econometric modeling regarding product and logic, and also demonstrating with a live data set that was really helpful for us to understand these both models. Apart from that, the interesting pedagogy of you, which I like the most, is like integrating your music with the mathematics. That was actually preferred by the Albert Einstein as well. So really thankful and great to know, get to have a session under your guidance today. Have a good luck and stay safe, sir.
थैंक यू प्रतीक जी। प्रतीक जी आप कॉमर्स में हो, मैनेजमेंट में हो, बीएचयू में?
Sir, I am in a management.
ओके,
Yeah,
ग्रेट।
yeah. Thank you, sir.
Madhu ji.
यस सर। सर ये एक्सप्लेनेशन और सब कुछ बहुत अच्छा था सर, और ये बहुत हेल्प किया हम लोगों को समझने में। थैंक यू वेरी मच सर।
Dr. Krishna. Dr. Krishna Murari ji. Okay. So, respected CP Gupta sir, you are a true
Thank you,
professor.
Sachin.
You are a true professor, sir. You are a true professor. The first session you cover Granzer causality. You started with what is cause and effect, actual cause and effect, and what is Granzer cause and effect. You have explained with data set, with eView software, and the most important, the conceptual clarity, which we have it after your session. Then logit and probit model. I think really all the doubts, all the knowledge related to logit model, probit model is clear, and this is real value addition in the knowledge. So thank you very much, sir, from the bottom of heart. Uh,
Thank you,
not,
Sachin.
not only this knowledge, we are learning so many things from you, sir, so many things.
Thank you,
And
sir.
that real feedback you are getting, no need to explain further from my side. Once again, thank you very much for your
Thank you,
all
Sachin.
support and cooperation.
Thank you.
Okay.
Thanks. Thanks, everyone. Thanks. Okay.
Sunita ma'am, you can continue about, you can announce about tomorrow's session.
Gupta sir, thank you so much for your nice session, and
Thank you, madam.
that was really very nice, like its alignment with the music.
Madam, I started with the session.
Please don't call me madam. You can call me Sunita. Don't call me
Okay.
madam. We
Sunita
are
ji,
like
I
children
started
to you,
this
students
session.
to them. We don't call.
I started this session saying that always start with a smiling face. So I'm seeing your smiling face. That's good. Keep it up. Okay, great. Yes.
Thank you so much, sir.
Yes.
Dear participant, tomorrow we have a session which is based on the application of a structural break and dummy variable. This session is going to conduct by the Professor Arindam Laha. He is from Burdwan University, West Bengal, and he is going to take a session with the help of theoretical aspect along with the software. So be ready. And in a second half tomorrow, we are going to take your one small test, which is based on the whatever you have studied in your previous 5 or 6 days. So don't worry, the test will not be very tough because majority of people they feel that test will be tough. It's very simple test, but be ready. All study material we have shared you day wise, and today's session also we are going to share the study material. Plus some study material we are going to share you in advance, which is based on the structural break and dummy variable in a today evening. Okay, so tomorrow be on time. And meanwhile, again, we are leaving this session open for the few minutes, 10 to 15 minutes. You can do your hand practice, and even you are facing any problem, so you can share your message with us. So, like if you are going to share some messages, we are going to carry forward this message to the concerned person, and accordingly, whatever the solution we'll receive by the resource person, we'll share with you. Okay, thank you so much.